Hello everyone, this is Brock Skaggs, and I'm going to make this video to cover the lecture content for this week. I will not be able to attend our usual class meeting tomorrow morning on campus, so I'm hoping to substitute my usual lecture with this video that you can watch throughout the week. So this week in the tutorial we're looking at Chapter 7, talking about parent-child relationships and the born technique. Parent-child relationships are going to be something that you're going to want to be aware of, and the born technique is something that's kind of a legacy concept that dates back to earlier CAD softwares there, and we'll just kind of touch on it. And they'll also throw some other stuff in there like configurations and suppressions and stuff like that this week. So what are we talking about with parent-child relationships? Well, inside of SOLIDWORKS, you notice you're building this tree structure on the left-hand side when you're working with parts, like I've got a part here on the screen now. And you can start to see as I hover over these things, you'll see a little icon off to the right there where I've got a little circle and then an arrow going to it. That's starting to illustrate these parent-child relationships. And the idea is this cut extrude one of its parents is going to be this boss extrude one, because for the cut extrude I used that face right there as the sketch plane to draw that circle. And so as you build these complex models, you basically form all these different parent-child relationships. And you do have to be worried about that because it can come back and bite you if you're not careful. And so an example of that is on this particular model. If I come in here and I edit the dimensions of this initial boss extrude, so instead of making it a 2 by 2 square, let's make it a 1.25 by 1.25 square. And if I hit Control Q right now and rebuild the model, you'll see I get an error, and this is because of a parent-child relationship. And so I'll close out of this dialog box now, and we can kind of investigate what this error means. And so if I look at this cut extrude feature, you'll notice, without even going into the sketch, that hole, which you can see the circle of it right now on the screen, is dimensioned from the origin, which is this very bottom left point. If I put it in the top view here, oops, there we go. You can see this hole is way off here in space, and the error that SOLIDWORKS is giving us right now is the fact that I'm doing a cut extrude, but I'm not cutting through any material, so SOLIDWORKS isn't liking that. And so I bring this up with parent-child relationships because if I would have modeled this a little bit differently, I could have kept it from erroring out at this point. It's just the fact that I'm referencing this origin and specifying 1.75 by 1.75 that I'm getting this type of error when I change the size of the square underneath it. So let's go ahead and modify this a little bit. And here we're going to basically be changing this parent-child relationship, the nature of it. And so I'll go ahead and delete those dimensions, and let's say instead of having those dimensions, let's say the real design intent was to have this hole specified from this top right vertex and be located a 1/4 inch from either side there. Now notice I can exit that sketch, and now I have the same model except for without the error, and I can go ahead and build this back out, make this 2.0 and 2.0, and I'll go back to that original state of the model when we just started the video. And so that illustrates this parent-child relationship. This cut extrude is referencing this boss extrude, so if I edit this boss extrude, I could potentially influence this cut extrude in negative ways. One way that SOLIDWORKS allows you to also look at these parent-child relationships is just by right-clicking the feature in the node, and then from the context menu, you can see this parent/child item. And so as I click here, you can see the child is itself, the cut extrude one, and just like we were talking before, it's referencing this boss extrude one here, as well as sketch 3, which is the underlying sketch where that circle's been drawn. But essentially what we were doing in the example is we were modifying this boss extrude one and at first negatively impacting our cut extrude one. So things to be careful of as you're working through more complex models. And speaking of more complex models, these can get rather large, so I'll go through some of the slides here. Here's an example of a foot of kind of a K'NEX or Lego style Iron Man feature, and notice here I've got a fairly large feature tree on the left hand side. You can see it's so large that I've got a scroll bar showing vertically here, and I picked a feature that's fairly high in the tree, and so you can see all the long list of children that depend on this boss extrude 3 feature here. And so that's just one thing we need to be careful of when I'm modifying the boss extrude 3 feature is I have the potential to impact all of these different children. And so hopefully that all makes sense. Another thing that the Chapter 7 tutorial is talking about is the BORN technique. BORN is an acronym standing for Base Orphan Reference Node. And the idea here is you build these parts as a bunch of parent-child relationships, but that first feature is really an orphan. It doesn't have any parents there, since the base orphan idea. And inside of SOLIDWORKS, that base orphan is really the Cartesian system that I start with, right? Before I create any solid geometry, you always start off with these planes here and the origin there. And that would be that base orphan reference node. We're always starting with that Cartesian coordinate system, that origin place, and then we're building on top of that. That's not something that we're having to define ourselves. Usually that's brought in right with the template there. And that's where I say things like, hey, SOLIDWORKS makes this a little easy for us. It's taking care of a lot of that, and we don't have to consciously think about that. As far as saying, hey, I've got a 3D space, I don't have to consciously put the origin in there, then put the planes in there. That automatically comes with the part template. Rebuilding the model is something else that I did want to point out. We saw that a little bit here. When I was modifying these dimensions, so I'll go ahead and modify like this one right now, you'll see in SOLIDWORKS that I've changed the dimension itself. Notice it's saying 5 here, but at this point the geometry hasn't updated yet. So I'll go to the top view and you can see that edge is supposed to be 2 inches long, this edge is supposed to be 5 inches long, but they still look the same length. That's because this model has not been rebuilt yet. It's kind of stale, it's out of date, if you will. And one way you can see this is on the left hand side in the tree structure, on this very top node referencing the overall part, you can see the little stoplight symbol that's saying, hey, this thing's out of date, it needs to be rebuilt. Same thing down here on the individual features that need to be rebuilt. And so how you actually go about rebuilding the model and kind of refreshing the geometry is you can come here to the very top toolbar and you can hit Control B is one way to rebuild it, but I also force a kind of harder rebuild usually by hitting Control and Q on the keyboard as well. And that's another way to get a different style of rebuild that for me personally is just part of my normal modeling process. I'll go ahead and build some features, I'll modify some things, and I'll just hit Control Q to then force the rebuild at that point. So if you're modifying existing sketch geometry, which is what I'm doing here, and you see things aren't automatically changing, I suggest you just go ahead and hit Control Q on the keyboard, and that should force the rebuild at that point. Alright, go past these slides, which brings us into this idea of feature suppression, which will tie right into configurations. And so feature suppression, I can go ahead and just use this model that we've been working with, is the idea of I want to turn off a feature from the model. And so when I say turn off, I really don't want to delete it. I want to still retain that information, but I don't want it to be active, if you will, at this point. And so what you can do with these features is suppress them to achieve that functionality. So for instance, this cut extrude, let's say we want to have a version of this plate without the hole. And so I can right click on it, and if I look through here, I'll go ahead and expose it out. I don't really see anything that shows it right here in the context menu, but it does live up here in this quick access item. You can see it where it says suppress there. And if I click it, notice it kind of gets grayed out here in the feature tree, and also on the model itself it is no longer visible there. And so that would be in a suppressed state. Basically, SOLIDWORKS, the model has retained the information about that feature, but it's not actively applying that information to what's on the screen at this point. You can always come back to it if I right click on that and go unsuppress. And now it comes right back. And you'll notice the icon looks slightly different. When I suppress it, the colored blocks on top and the gray ones on the bottom, the arrow points down. If I need to unsuppress, notice it goes in reverse. The colored one's still on top, the gray one's on bottom, but now the arrow is pointing up, saying I'm going to unsuppress it at that point. And so one thing you may be thinking about, okay, why would this be of any value? One thing you could do is potentially decrease the amount of time it takes to load the model. If your model had a whole lot of features and sometimes you didn't want to see some of these and they were like really complex features like thread geometry or something like that, you could suppress those geometry elements and then the model would load a little bit faster. This also leads into things called configurations, which is what I've got here. And so configurations are very powerful. At the company I work with, H.E. Williams, they do a whole lot of stuff with configurations, partly because their product line, they have very similar parts, but they just change by size. And so to kind of talk through that a little bit, when you look in the ceiling, a lot of times, I think probably in the classroom that we have back on campus, you've got a bunch of tiles up there. It's a grid-based system. And so you've got these tiles that are basically 2 foot by 2 foot, and you can make 2 by 2 fixtures. That is 2 foot by 2 foot or 2 foot by 4 foot fixtures. And so sometimes we share the kind of part geometry between those, but they just need to be changed in the like one dimension. Like that 2 foot needs to become a 4 foot version as well. So instead of making independent files that then you'd have a bunch of redundant items in each one, you make a single file and you can change that length as a configuration changes there. And so to bring it back to a Margaret lecture example, I've got an assembly here. And it's a fairly simple assembly, right? A bunch of Allen wrenches or hex keys, however you want to talk about them. And they've got a little holder here. And so the question is, how many part files, and I say part files, I mean SLD PRT files, did it take to make this assembly? And so if you didn't know anything about configurations, you'd say, well, I've got 1, 2, 3, looks like 4 different sizes of the hex keys or Allen wrenches, and then I've got a holder, so you'd say, hey, it takes 5 SLD PRT files. That would be one way to create it, but with configurations you can actually do this with just 2, which is what I've done here. And so I'll go ahead and open up the Allen wrench, and it's a very simple part file. You'll notice I just have the one feature, but now if I go to this tab here, it's called the Configuration Manager. Usually with most parts, if you don't use configurations, it'll just say default and there will only be one node here. But now I've got 1, 2, 3, 4 nodes, and as I double click them, you'll see the size of the Allen wrench is changing there. And so these would all be considered manual configurations, and notice I'm basically updating the geometry for each one of them. And so this can become very, very handy. It's very convenient when you're modeling parts that are related to one another. And so I believe online I've got a very nice YouTube video that goes into this in a lot more detail. But just to show it with, again, this one example we keep playing with, let's say, for instance, we have a plate with a hole in it and a plate without a hole in it. And so I'll go to the Configuration Manager. I'll go to the Properties, and I'll say this one's with hole, because we've got the hole in it, and I'll right click on the top node and I can say, hey, I want to add a configuration, and I'll just call this the no hole one. And so at this point I can double click on each one of these, making it active, and really there's no changes at this point. But one thing I can do with the no hole one, no hole configuration active, I'm going to come back to my feature tree and I can right click on the cut extrude one, that's the hole feature, and I can configure the feature. I'm getting something about a txt file. It's a properties.txt file. That's okay that I can't locate it. And so I've got this now table structure that's saying, okay, I've got a configuration with no hole. I'm looking at the cut extrude one, and do I want to suppress it or not? Well, in the no hole version, I want to suppress it, right? I don't want to have the hole in the part. So I'll hit OK there. And now notice it's removed from the part and cut extrude 1 is suppressed. You can see the act configuration is right there. It says no hole. But now if I come back and double click with hole, the hole comes back. I see the name there, and the cut extrude 1 is now not suppressed. It's an active feature at this point. And so that'd be an example of using configurations to toggle the suppression state of a given feature. And you can also do this to modify dimensions as well. So for instance, I could possibly make one of these have a 5-inch dimension for this length, the other have a 4-inch dimension for the length, or a 2-inch. And so I guess since we're talking about it, I'll go ahead and do that real quick. If I can right click on that dimension, I'll say configure the dimension. Okay, again hitting OK for that properties.txt. And I get a very similar table. The configuration name is no hole and with hole. So let's say with hole we want it to be 5, and the no hole we want it to be back to 2. So I'm just now setting that dimension's value based off the configuration. I'll hit OK. Notice I need to rebuild at this point. You can see the stoplights there, so I'll hit Control Q. And now let's go back and see what happens. With hole, we got this longer width. With the no hole, I got the shorter width and the hole's gone. And I can go and toggle between these. So that's a very quick demonstration of some of the things you can do with configurations at the part level. Okay, so some of the things I wanted to talk about, again, to kind of aid the Derby competition, is it is possible to actually draw curves in SOLIDWORKS through tabular data. And so the example here comes from the kinematics class, where they study how to create these plate cam designs. And so the cam that we're talking about is kind of like a cam follower mechanism, where I've got to come up with this shape so that I have a follower that moves in a certain way throughout time there. And if you take the MECET 420 class, you'll learn about how that actually happens. But for our application, basically what you end up with is an Excel file with a bunch of points, where these points are described as X, Y, and Z, are the values in columns A, B, and C. And then what we do is we need to take this tabular data and say, hey, hey, SOLIDWORKS, be able to consume it and draw a curve using it. And it's a fairly straightforward process. You can basically get into Excel, come up with your mathematics in order to describe these points, and then you can save it out as a simple text file. SOLIDWORKS can't read an Excel file, an SLSX file, for instance, but it can read a simple text tab delimited file. So that's what we're doing here. And then you can go to Insert, Curve, Curve through XYZ points, and it'll actually allow you to browse that, and you'll upload that into SOLIDWORKS as a generalized curve feature there. So you can see the preview that I'm showing there and how it's consumed all of these data points. And so that's one way you could do it. I'm thinking back to the car design, if you were trying to create some sort of aerodynamic fairing, if you will, for your car, and maybe you get online and you can find some mathematical relationships or equations that describe how the different cross sections should look, then you could conceivably use those mathematical calculations to define the cross sections, bring them into SOLIDWORKS through this curve generation process, and then stitch things together, for instance, with a loft type feature there. To kind of drill this cam problem home a little bit as far as the application that I'm showing here, you might have a problem where you have a follower that's got to go through these motion steps. You have a cam angular velocity, how fast it's spinning at 28 RPMs, and then a little bit of information about the cam itself. And with that, you could define the follower, bring the profile into SOLIDWORKS just as we had described. Oops, let's try Windows Media Player here. And what you would end up creating is something about like this. And so this cam profile and that kind of blue curve you're seeing was created using the steps we're talking about now. Okay, and that brings us to the end of all of our slides here. So hopefully that is all making sense. And hopefully that kind of gives you a taste of what configurations look like, in terms of how they could be useful to basically create these related families of parts itself. Hopefully it opens your eyes a little bit without these parent-child relationships. Most likely you'll feel these when you go to make a change and your model kind of blows up, kind of like we were seeing those errors happening with this one when I had the whole dimension relative to the bottom left point there. And so just kind of have that in the back of your mind as far as, hey, that's what's happening, and hopefully that'll help you fix your model at that point. Alright, so with that being said, I think that covers everything I wanted to cover in this video. The other items for the week, do check Canvas for notes on the homework assignments as well as the quiz that we'll have this week as well. And also do not forget about the Derby project that we have running at this point throughout the semester. It kind of runs in the background. So you should be modeling up your individual parts, kind of getting to the point where you can start assembling those into car assemblies at that point, and start to actually kind of make these things a little more concrete than what we saw a few weeks ago when we were doing the intro presentations. The other thing I just wanted to mention as well is do not forget about the CSWA additive manufacturing exam that we have toward the end of the semester as well there. I talked about it briefly last week. I pointed you to a resource on mysolidworks.com where you can create a login set of credentials and have access to the study curriculum there. So I would suggest you kind of get in the habit of maybe watching a couple of those videos a week. They're very short, they're 10 minutes or less for most of the videos, so you can kind of start soaking in that information there, so that way you know things about like what types of printers there are out there. You know things like what does FDM stand for, what does SLA stand for, what does it mean by infill, and those type of concepts that you'll need to know for that exam. Alright, so I guess that's all I needed to say at this point. So thank you for watching the video and have a good week.